be equal, okay? So let me tell you, like it is a square minus b square, right? So you can write down a plus b into a minus b. That means a plus b into a minus b, okay? So I think now you can cancel on minus root over on minus x square, on minus root over on minus x square, right? So again,
Okay.
you get this one, like x square by root over x minus x square plus 1. So minus x square plus 1, this term and this term, on minus x square, they are the same, okay? You see?
Yes, yes.
They're the same. So I think you don't need to factor out -1 here. So they are just elaborating all those things. So yeah, we can just think more simply. So
Okay, okay.
yeah.
So,
So guys, is this clear now? I think we have gone a long way, just doing nothing. Okay.
no, it was hard to understand, but yeah, now it's
Yeah,
clear.
yeah. Okay. So let's go back here. Okay. So now we understand that this part on the denominator. So this part is a square minus b square. So it will become a plus b into a minus b, and then we can cancel the minus term, right? And we only get
Right.
the plus term. Okay. Right. It was very simple, but we mixed it up. Okay. Now let's go back here. So on the right side, we have integration of 0 to 1 and all these things. So we can also write down this way. A square minus b square. That means a plus b into a minus b. And we can cancel the minus term. And again, we get the plus term, okay? So you can see that this part and this part, this part and this part, they are the same function, right?
Right.
They are the same function, but only the change is here. Here in the
Limit.
limit, right?
Yeah, limit.
Yeah. So the change is in the limit. So what can we do now? We have to change it and we have to, okay. So our target is we have to make something like simpler, okay? We have to make it simpler. Like we have to make it in online so that we can just find the integration of on, and also we can calculate the integral of root over on minus x square, okay? So our target is something like this way, that we want to make it as a single line, okay? But this function here, this is like a we have a numerator here and also a denominator. So we have to break down it and we have to make it as a single line, okay? This is our target, because if it is a single
Okay.
line, then we can calculate easily. Okay, but this math is not easy, okay? Oh no. Okay, fine, we get it. So here is x square by on plus root over on minus x square. So if you multiply on the upside and downside using that is called the opposite sign, okay? So now we will only work with the denominator. Now we will only work with the denominator. So we call it conjugate. We multiply the denominator with conjugate, okay? So on upside, we multiply with conjugate, and also on the downside, we multiply with conjugate, okay? So this part, this is only this thing, okay? So this part is only for the denominator. Okay, guys? You see here, I took this part and I multiply by the conjugate. I multiply by the conjugate of this. So here is a conjugate, means here is plus sign. So I just multiply with opposite sign, okay? On upside and also downside. So you know that upside and downside, they can get cancelled, right? And we again get back to our main function. So now the interesting part is, this one is a plus b into a minus b, right? So we can write down a square
Right.
minus b square. A square minus b square. And then if we just calculate here, so this root and square, they can get cancelled, and we get only okay, let me calculate this part. Okay, it is 1 square, that means 1 minus root and square, they can get cancelled, right? So we get on minus 6 square. So you see here, on and on, they can get cancelled, and we get minus 6 square. Okay. Yeah. Where is minus? So here will be a minus. I didn't write here, okay, because maybe by mistake. So here it will be a minus x square, okay, and here will be also a minus. So you know that this part and this part is similar, right? So I don't need to explain this part, okay?
Yes, yes.
Guys, can you understand?
Yes,
a
yes.
little bit, yeah.
Okay, a little bit. Okay, let's.
We just basically just simplified it to.
We're just simplifying
x,
this part. A square minus b
okay,
square.
okay.
That means a plus b into. So it was a plus b into a minus b. That means a square minus b square. So why do I multiply? Why do I multiply by the conjugate? Okay, because I am trying to remove this root. Okay, I am trying to remove this root over sign. And also I am trying to remove this x square, okay, because you can see here we get online, we get just a single line, okay. So if I multiply by the conjugate here, so I get on a square is I get a plus b into a minus b. So a plus b into a minus b is equal to a square minus b square. So on a square, that is 1, and this part a square and root, they can get cancelled. So we get on minus 1. Oh, sorry, here it will be plus. Okay, I was right. Okay. So guys, see here, we had minus multiplied with this 2 term, right? So minus so on a square that is equal to 1, and minus 1, that is minus 1, and minus multiply x square, that is plus x square, right?
Right.
Okay. Guys, can you understand now?
Yes, yes.
Okay. So this minus was multiplied with this one, and also with this x square. So we get x square by 1 minus root over 1 minus x square. Okay. So now if I take this on upside, if I just take this on upside, so it will become x square. So division, it will become if I just make it upside, so it will become reverse. Yeah, so multiplication 1 minus root over 1 minus x square divided by x square, right? So this is our main division, okay? This is our main division. So if I take this whole part on the upside, so they will, it will become upside down, okay? So now we can cancel x square. Guys, can you see? We can cancel x square. So we get a single line.
Okay,
so
okay.
This is what we are wanting for. Like now we are getting some. Now we have simplified this, right? So we have simplified the function. So we have to use substitution rule at this moment. You see here, we have x square. So inside of root we have x square. So we have to use substitution rule because we have because here there is 2 function. We cannot calculate this part easily, okay? So okay. So now look at this part. You don't need to look at this part because they are the same, right? 1 minus root over 1 minus x square, 1 minus root over 1 minus x square. So they are same, okay? Just change it on the limit. So now what can I do? We can just we can use sum rule here, okay? So we can just take integration of minus 1 to 0 on dx, and this minus is here, integration of minus 1 to 0 root over 1 minus x square dx. Okay, we just divide, this is called, so we just use sum rule here. Okay, you see here. Okay, let me show you the formula. The formula is here, property 1. Okay, integration of a to b f of x plus g of x dx, it will be integration of a to b f of x dx plus integration of a to b g of x dx. So this is the property 1. Guys, can you see here?
Yes.
Yeah.
So according to property 1, we can write down this way. So this part, it will, okay, let's calculate this small part, that is integration of minus 1 to 0 on dx. So we know that how to calculate. So to calculate this, we have to find the integral of this function. Okay, so this function is called f of x. So to calculate this part, we have to find the integration of f of x. So it is written at this way, like capital letter F and x, capital F of x. Okay, so we have to find capital F of x. So capital F of x means the integral of this function. Okay, so this is 1. So integration of on, that will be on x. Guys, do you remember integration of any constant? Integration of k dx is equal to kx plus
0.
c. No, this is integration. This is not differentiation. Kx plus c. So it was for indefinite integral, right? But for definite integral, that one we are solving now. So it will be, we can just omit this c. Okay, it will be kx. So integration of on, it will be on x. Okay, and here is our limit. So now we have to, okay, so firstly let's calculate this part, firstly. Okay, now give back the integral here, give back the limit here. Okay, so firstly we have to calculate f of b, and then minus f of a. Okay, f of b minus f of a. So to calculate this, this 0 is our b, and this minus 1, this is our a, right? So let's give back, let's give the limit back. Okay, so if we just use 0 here, so on multiply 0, that is 0. Okay guys, this 0, and we know that formula is f of b minus f of a. So f of a, that will be, you just give this back. Okay, so this is minus 1 multiply 1, that is minus 1 minus 8. Yeah, this will be plus 1. Okay,
0 minus, yes.
Yeah. Oh, here is the here is computing boundaries. So how do we compute the boundary? So integration of a to b f of x dx, it is f of b minus f of a. So this capital letter F, it represents integration. Okay, integration of f of x. So you see here we had x here, we had on here. So integration of on, that is x, and now if we just substitute the limit back here, so we will get 0, and minus, this is f of b. Okay, and minus fa, that means we just substitute minus 1 here, so minus 1 is minus 1. Okay, so f of b minus f of a. Guys, you can see here the formula, f of b minus f of a. So minus and minus, that will become plus, so 0 plus 1, that is plus 1. So ultimately we get +1. So is this clear now?
This is good.
So this part, integration of -1 to 0 on dx, this part will make only 1, okay? Only 1. So I calculated this part here, okay? So now let's go here, the difficult part. So it is integration of -1 to 0 √(1 - x squared dx. So we have to use substitution rule here, okay? So if I just let x squared is equal to u. Oh, I used trig substitution, okay? Trig substitution. Like this part here. This is √(1 - x squared. So I can just
u is √(1 - x squared, right? Or is just x squared?
No, trig function is this way. Like if we have something like √(a - bx squared, if we have something like √(a - bx squared, so x will be is equal to √(a by √(b sine u, okay? √(a by √(b sine u. So here a is equal to what? A is equal here a is equal to 1. So √(1 is also 1. And b here b means the coefficient of x square, right? So b is also 1. This minus is the minus of formula, okay? So b is also on here. So √(1 is that's also 1. So it will make 1 by 1 sine u. So 1 by 1 sine u means sine u. Okay, guys. Do you understand trig substitution?
Repeat this one.
Huh? So if we
Please
get something
repeat.
like this way, like √(a - bx squared,
Then
we
it's
get
x
yeah.
√(a) or √(b).
Yeah, so it will become
Sine u.
So x will be equal to √(a by √(b sine u. So here a is equal to 1. You see here a is equal to 1.
Yes.
And here b is equal to also 1. Like if we compare this part with this trig substitution, so √(on by √(on), that means 1 by 1. 1 by 1 also means 1. And so that finally it will become sine u, okay? Sine u. 1 by 1 sine u, that means sine u. So this is the trig substitution rule. So, okay. So we get here sine u. Let me write down, okay? So for this part, using trig substitution, we can write down x is equal to sine u. So maybe not x, it will be u. U is equal to sine u. So x equal to sine u, sorry. X equal to sine u or x. X equal to sine u, okay. Yeah. So look at here. So we get x equal to sine u. So if we differentiate on the both side, now we differentiate on the both side. So it will become dx and it will become d sine u. So d sine u means derivative of sine u into du, right? Into du or dx. Dx maybe. D sine u dx. Du, okay. Cos square u du. Yeah, so now we differentiate on the both sides. So dx and d sine u. So d sine u, do you guys remember the formula? dy is equal to y derivative dx. Okay. Dy is equal to y derivative dx. So we have dx here. So dx. So we have d sine u. So d sine u will be sine u derivative, sine u derivative
dx.
dx. Okay. So do you remember that formula, a small formula?
Yes, yes.
Yeah. So dx will be is equal to cos u du, because derivative of sine u is cos u, right?
Cos u, yes, yes.
Okay. Not x, here is u. Okay. Now let's go back here. So we get cos y cos square u. Okay. On minus sin square u cos u. Oh yeah, we had okay, so I see. Okay. On minus sin square u is equal to we let u is equal to, finally, that is on minus sin square u into cos u du. X equal to sin u, right? We let x equal to sin u. Okay, got it. But no, we get x equal to sin u here, x equal to sin u. So now, okay guys, can you look here? Let me zoom in. So see here, we got x equal to sin u, right?
Right.
At the beginning, when we applied direct substitution, we get x equal to sin u. So here in x, we can write down sin u, right? Here in
Right.
x, we can write down sin u. So look here, I write down sin u. So it was not x, it was x square, right? So sin u will become sin square u. Okay, guys?
Okay, okay.
So we get on minus sin square u. So on minus sin square u, that will become cos square u. On minus sin square u, that will become
Okay, yeah, okay.
cos square u, right? So this is the formula. So we know, sin square theta plus sin square a plus cos square equal to 1, right?
Yes.
Yeah,
So on minus sin square, this will be cos square u. And now this square and this root, they can get cancelled. Okay, so we get cos u, and here we had another cos u. You see here, why another cos u? Because here is dx, right? So dx equal what? Dx equal, you see here, dx equal cos u, right? Cos u du. We calculated here, right? Dx equal
Yes,
cos
yes.
u du. So for this dx, we can write down cos u du. So you see here this cos u du. So cos u du and cos u, that will make cos square u du. Am I right?
Yes, right.
Okay. So finally we get cos square u du. So where did we start? Maybe here. So guys, from this part to this part, do you understand? I
Yes,
just
yes.
written all the steps here. Okay, I have
Yeah,
written
it's
all
clear
the
now.
steps here on the right side. So that's why it took me 2 days to complete and finally understand all those. Because
Yeah, it's a very complicated question.
yeah. Maybe Lausi can make it more simple here, but I'm also a beginner. Okay, so what is that? Yeah, this line. So we come up to here, this line. So cos square to u, there is a formula. cos squared u, that means 1 plus cos 2u by 2. Okay guys, this is the formula of TX function, cos square u. Let me show here. Cos square x formula. Where is the formula? Cos square u. Okay. You see here, formula cos square x, that is 1 plus cos 2x by 2. Okay. Formula for lowering power. See here, guys.
Yes.
Formula for lowering power. So cos square x, that is 1 plus cos 2x by 2. So we can write down 1 plus cos 2u by 2. Okay.
Oh, okay. No, I
Yeah.
see.
So now let's move. Oh, okay. There is another important thing. So when we use substitution rule, we must change the boundary. Okay. We must change the boundary. We must change the limit. Okay, guys. So how do we change the limit? So you see here, adjust integral boundaries, right? So we let x is equal to sin u. Guys, do you remember here? We let x equal to sin u. See here, x equal to sin u, right?
Right.
So to adjust the boundary, or to adjust integral boundaries, we have to keep u on the left side. Okay. So if we keep u on the left side, and if we take this sign from right to left, so it will become inverse or arc. Okay, it will become arc sin x. Okay, guys.
Okay.
So if we take sine from on side to another side, so this will become arc sine. Okay, and we had x here, so u is equal to arc sine x. So is that clear?
Yes.
So u is equal to arc sine x. Now we have to substitute the boundaries here. We have to substitute the boundaries here. So we have before substituting before
Minus one.
before computing the boundaries, we had before u substitution, we had the lower limit minus 1 and upper limit 0.
0.
So we have to substitute the 0 and minus 1 in the main in here. Okay, in here. So firstly we substitute minus 1. So if you calculate it in calculator, so we can just take this minus out. Okay, so it will become minus arc sine 1. So sine 1, that is sine 90 degrees equal to sine 1, right? So 90 degree means pi by 2. Guys, do you remember
Yes.
the high school maths?
Yeah.
Yeah. So ultimately this minus and this pi by 2, that will make minus pi by 2. Okay.
Okay.
Yes.
So our, so for 0, for minus 1, we will write minus pi by 2. Okay, because we have used u substitution rule here. Okay, so now let's calculate the upper limit. Let's change the upper limit. Okay, so we just put 0 here because our upper limit was 0. So sine 0, that means sine 0 is equal to 0. Okay, so arc sine 0 is also 0. Okay, guys, you can calculate it with using your calculator.
Yes.
So now our limit got changed, and we get minus pi by 2 and 0. Now, okay, so we have come up to this line, right? So let's calculate here. So we can maybe take 1/2 out, because yeah, so we can take 1/2 out, okay, because this is the constant. We can take this 2 out, so it will become minus 1/2. It will become 1/2, and this minus is here, okay, so it is minus 1/2. So now we get it a simple line, right? Because now we don't have these two. Guys, do you understand? We just
Yes, yes, yes.
take
You
this
took it out.
constant. Yeah, I just took this constant out. So finally we get this line. So now we can write down integration of minus pi/2 to 0 on du, because here I'm just using the number on property, okay, this property. I mean the substitution rule. Sorry, substitution, not the sum rule. Okay, sum rule. So it is on du, and this part will be cos 2u du, right? Cos 2u du. So now, so we already okay, let's calculate this part on du. So we know that firstly, to calculate this, we have to find the integral of this function. So if we find the integration of this function, it will be x, right? So now we substitute back our limit. So firstly, upper limit, it will make 0. So 0 minus we substitute our lower limit. So lower limit is minus pi/2. So this is minus pi/2. Okay. So now this minus and minus, they will become plus. So ultimately we get plus pi/2. Okay.
Okay.
So now is this step like more simpler than before? We find this is our function. So this is our function. We just find the integration of this function. So integration of all, that will be x. So now we substitute back our limit. So firstly we have to substitute the upper limit, okay? So this will become 0. So 0, and this is minus, and now this minus is the minus for in the formula, okay? Do you remember FB minus FA?
Minus FA, yes.
Yeah. So this minus is the minus for formula, and we just again substitute back our lower limit. So this will become minus pi/2. So this minus and this minus will become plus. So ultimately we get plus pi/2. And for this part, okay, this is a cos 2u du, right? So again we have to use substitution rule here, okay? Because we know how to calculate cos u, but we don't know how to calculate cos 2u. So again, 2u is equal to our v. So to make it simple, I just okay, I just did it. Maybe I can do it here. Okay. So here our v is equal to 2u, right? We are not letting it as u again, because we have already u here, right? So we have to let something else. Like we can let Alex equal to 2u, okay? Or we can let Omar is equal to 2u, because we have already u here. So we cannot let u is equal to 2u, okay?
Okay.
Yeah.
Yeah, understood.
So that's why we let v is equal to 2u, okay? Then we have to differentiate on the both side. So differentiate on the both side. So we know that d2u, that will make a 2u derivative du, right? 2u derivative du. So okay, du or dv. Okay, so 2u derivative du. So derivative of 2u, that will become maybe 2, right? Yes, 2.
Yes,
so 2 du. Now if we take this 2 on another side, so it will become 1/2. That means 1/2 dv is equal to du, right? If we take this 2 on the left side, so it will become 1/2 dv. 1 by 2 dv is equal to 2 du. Am I right, guys?
Yes.
Okay.
Yep.
So for 2u, for du, okay, for du, we can write down 1 by 2 dv. You see here for du, we can write down 1 by 2 dv, right?
Right.
Okay. For du, we can write down 1 by 2 dv. So for du, we write down 1 by 2 dv. Okay. Now, okay, let me erase this. For du, we write down 1 by 2 dv, and we let already we substitute 2u, right? So 2u is v. Guys, remember?
Yes. Yes.
Yeah. So ultimately it is cos v 1 by 2 dv. So again we have to change the limit, right? Because we have used u substitution rule. So we let u is equal to sorry, v is equal to, we have only 1 minute left. Okay, so we will join again. V is equal to
Okay.
2u. So v is equal to 2u, right? So now we have to adjust the limit. So substitute 0 here. So 2 multiply 0, that means 0, right? So our upper limit
Yes.
is 0.
0.
So this is 0, okay? And substitute lower limit here. So 2 multiply minus pi, that means minus 2 pi. Sorry, sorry. 2u, right? It was pi by 2. So substitute pi by 2 here. So 2 multiply pi by 2. 2 multiply minus pi by 2. 2 multiply minus pi by 2. So it will become
Minus pi.
only minus pi, right?
Yes.
Yeah.